Okay, so today we're looking at furthering our understanding of binomial expansion. So our learning intention is the knowledge of using Pascal's triangle to assist expand binomials. We'll be successful, we can greatly construct the triangle and expand binomials where both terms are not equal to 1. So previously we were doing 1 plus something or 1 minus something to the power of something. So now we're doing where they're not. Okay, let's look at this one. And I'm going to do the same thing as before. If we had x plus y to the power of 0, well, that's just 1. If we had x plus y to the power of 1, we're going to get 1x plus 1y. If we did x plus 2 squared, okay, we're going to get 1x, 2xy, and 1y. And what I'll do is actually write in pencil, you actually got y to the power of 0 here, and x to the power of 0 here. Okay, because that's x to the power of 1, and that's y to the power of 1. So if I did x plus y to the power of 3, I'm going to get the coefficients of 1, 3, 3, and 1. Yep. So we're going to get 1x and definitely 1y. Okay. We're then also going to get x to the power of sorry, I lie. Yeah, cubes. Sorry. We're going to get x to the power of 2 and y to the power of 1. And then we're going to get x to the power of 1 and y to the power of 2. Okay. And if I was to continue on, so we've got 1, 4, 6, 4, 1. Yeah, we're going to get x to the power of 4 and y to the power of 4. But we're going to get x to the power of 3, y to the power of 1. X to the power of 2, y to the power of 2. And x to the power of 1, y to the power of 3, and y to the power of 4. So, what I want you to know is that the expansion of x plus y to the power n has n plus 1 terms, basically. Yeah. So here the power was 1, I get 2 terms. I get x and I get a y. Here the power was 2 and I get 3 terms. I get an x, I get a 2x, I get an xy, and I get a y. Okay? So the expansion of x plus y to the power of n has n plus y terms. And each of the terms, the powers and indices of x and y add up to n. So for example, here, I'll write in, this is y to the power of 0. 0 plus 4 equals 4. 3 plus 1 equals 4. 2 plus 2 equals 4. 3 plus 1 equals 4. 4 plus x to the power of 0 equals 4. 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. 3 plus 0 is also 3. So the powers of each term of x and y add up to n. The coefficients stay the same as a Pascal's triangle. So let's do some example. Alright. We want to expand 2 minus 3x to the power of 3. Okay, so we're looking at the third row. So we go 0, 1, 2, 3. We go 1. We get 3. We get 3 and 1. Okay. So what we do is we look at the first term. And here we're going to the powers for this term goes down. So if I start at 3, I go down the power. The second term, like before, we're going up. So we've got negative 3x. Start with 0. 3x. Okay. And we can double check because the powers are now adding to the n. Going through this slowly. Okay. Well, that's just going to be. I'll do it like that. We've got 1. I'm going to use the American. Okay, very small times. 2 to the power of 3 becomes 8. And that's just going to still become 1. Okay. If I did this part, I've got 3. 2 to the power of 2 is 4. That's going to be negative 3x. Okay. Looking at this one, we get 3. I'm going to times it by 2. This is going to be positive 9x squared. In the last term, we've got 1. We're going to get 1. Negative 27x cubed. Okay. So 1 times 8 is 8. This is negative, so we've got 3 times 3 is 9, times 4 is 36x. This is going to be positive, so 3 times 2 is 6. This is going to be 54x squared. And then 1 times negative 27 is negative 27x cubed. Okay, so the only difference is here is that these terms are not 1, and so we're going to start with by decreasing the powers. Okay, so here we've got line 4, so our coefficients are 1, 4, 6, 4, 1. Start with the first term, so it's 4x. We're going down. So that's power of 4, 4x to the power of 3, 4x to the power of 2, 4x to the power of 1, 4x to the power of 0. And then here we're going up. So we've got 2y to the power of 0, 2y to the power of 1, 2y to the power of 2, 2y to the power of 3, and 2y to the power of 4. Okay, I'm just going to put little brackets. So that's 1. 4 to the power of 4 is 256. And 2y to the power of 0 is just 1. It's all positive, so we can put the plus sign. That's 4. 4 to the power of 3 is 64. Plus 2y. Alright, so that's 6. 4 squared is 16. Plus 4y squared. Times 4x times 8y. Plus 1 times 2 to the power of 4 is 16. Y to the power of 4. Okay, so our final solution is 256 x to the power of 4. 4 times 64 times 2 is 512 x cubed y. 384 x squared y squared plus 128 xy cubed, plus 16 y to the power 4. And you might want to double check that all powers, if you add the powers, they all add up to 4. So that you know that you're correct. Okay. So last example, we're going to row 6. 1, 2, 3. So row 6. 1, 16, 15, 20, 15, 6. I'm sorry about that. I'll put 1 down here. Okay. So we're going down. 3 over 5. We're going to start power 6. Okay, and then we're going to go up. Okay, so we've got 1. Okay, 3 to the power of 6 is 729 x to the power of 6. Now 5 to the power of 6. Okay, times 1. Okay, we've got 6. It's positive. 3 to the power of 5. And then 5 to the power of 5. Times 2y. Okay, we got 15. 3 to the power of 4. We get 81. And then 5 to the power of 4. Times 4y squared. Okay, 27 x cubed, 125 times 8y, 15 times 9x over 25 times 16y times 3x over 5 times 2 to the power 5 is 32 y 5 plus 1 times 1 times 2 to the power of 6 is 64 y. Okay. So we get 729 x to the power of 6 over 15,625. So 6 times 243 times 2, 2916 over 3125. Okay, so we've got 15, so 15 times 81 times 4 over 625 is 972 x to the power 4 y squared over 125. Okay, 20 times 27 times 8 over 125. We get 864 x cubed. That should be y cubed. Over 25. So we get 15 times 9 times 16 over 25. So we get 432 x squared y to the power 4 over 5. Okay. 6 times 3 times 32 over 5. We get 576 x y to the power 5 over 5 plus 64 y to the power of 6. Yep. So always make sure that you're adding up your powers as you're going along. Yeah, so you can spot errors as you're going through. Yep, and that's it. So remember, for these ones, you're going to have to go down for the first term and going up for the second term. Okay, good luck.